Hi, my name is Nils Helse, and I'm one of the CEOs and co-founders of DigiFarm, agtech startup based in Norway, and this is our final closeout report for Fund13. Project ID 130019, and the title is Minting NFTs from Historical Agricultural Field Boundary Crop Performance. And we've been lucky to go through Fund 11 and Fund 12, which was part of the data layers that we were building up towards this Fund 13. And specifically before we had this project, we were actually looking at identifying field boundaries or digital identities for farmers in Kenya and Tanzania specifically. And really in this part of the project, this fund, we were really looking at, digitizing crop historical performance. So really, what does that boundary or crop look like over a 40-year period in terms of productivity, which we measure from satellite data and vegetation of the crops. And this would really feed into being able to unlock value for microfinancing and insurance schemes in these countries, which is one of the major problems, of course, of smallholder farmers. But again, this is the project, and we had 4 milestones. This is the final milestone, which we're now submitting, and with that, of course, the final report. And I figured I'd show a couple of examples of the work we've actually completed during this project, and I'll start from the very basics actually, starting with showing a very blurry picture. So starting back from the beginning, really one of the key challenges here is looking at agricultural land in Kenya, which was our first area of interest. And when you look at agriculture or smallholder markets, the field boundaries are very small. So typically what you see here, this is a Sentinel-2 picture or image from European Space Agency for Kenya. Sentinel-2 is the highest publicly freely available satellite data at 10 meter per pixel, but we can't see the boundaries. So I can't delineate them, and then you can't create like a historical database for one unique field or digital identity, so to say. So it's problematic. But what we've done is we developed a super resolution model, which basically is an AI model that increases the resolution from original 10 meter to 1 meter per pixel. So you can see the right-hand side, you can actually see the boundaries, you can see some single trees, and this is really important for us to be able to actually then layer on top automatic detection of field boundaries, so homogeneous crop zones, so one crop, one field, and then layer the historical data on top. But I figured it'd just be of interest to just show this, and I'll also maybe just jumping here quickly, also show the coverage map that we have now been working on in Kenya, so you can actually see where it's present, and eventually I'm going to get to the actual gritty stuff of you seeing the final demo. You can see here, these are the areas that we focused on in Kenya, kind of around Nairobi, which is the fairly most heavy dense agricultural area. And yes, and then swapping over here, you can actually see some polygons, some kind of boundaries or geometries. And really what this is we actually looked and worked with a local partner to actually look at what does the field boundaries look like when they're digitized manually by GPS. So it means a farmer or a field agent goes to the field, has a smartphone usually, and walks around. And typically what we see is that you can actually see here, these purple lines is the actual boundary that's been recorded. And of course, it's very expensive, impractical, time consuming, and it leads to being pretty inaccurate, as you can see too. So really our task was to look at, can we delineate the boundaries at a higher accuracy than what you have in the GPS data? And you can see here part of the data set comparing white lines with the GPS, which is the automatic delineation is a much higher accuracy. So yes, okay, so once we have the boundaries for the AOI, then the next step was to look at this kind of historical data. So what we use is actually 40 years of Landsat data, which is a satellite from NASA, which actually measures the productivity of vegetation over time. It's a little lower resolution, but here is an example of the first case where you can actually see red parcels or polygons are the ones that are performing lowest and green are higher. And all it means is actually that we take one image from each growing season, so one image over 40 years, and then we look at the highest vegetation peak, and we measure that in something called NDVI, but it's basically just the biomass from the crop, a level, so to say, from 0 to 1. And then we see if it's increasing or decreasing, and the red ones are decreasing and the green ones are increasing. And there's two ways this relates to this project. One is that actually when you have red polygons, it has a lot of upside potential. So when we think of carbon credits, of course, or regenerative agriculture, which would help replenish the soil, for example, and also be able to increase productivity over time and biodiversity, of course, this unlocks a whole nother value chain and product for the farmers in this area. And the green ones are obviously where you can think of, you get better insurance premiums or microfinancing, where you can actually prove by this digital identity that you've done production on this piece of land over the last 40 years, so to say. And then we get to the final product. So sorry for the long introduction, but you can see here, this is the output of the Fund13, where you can actually see we've delineated all the field boundaries based on what I mentioned of the super resolution data, and then we take the last growing season, the biomass from the satellite, and then we detect what the whole crop homogeneous zones are. And then on top of that, we digitize, of course, the sustainability index, which is the 40 years of crop history, into this one kind of packaged NFT, so to say. You can see them here actually, and this is now fully functional. And also to mention, there's 20,000 boundaries here, and this is of course all verifiable on the chain now. So you can actually, of course, see all the NFT data. And I'll just maybe open up here so you can actually see the data here. Sorry for the ring, but you can see all of it is listed here, both in, of course, Explorer and also pool.pm, where you can see. Oh, I will go back and find the correct link. Yeah, but anyways, yes, so you can see it all here. You can log in, you can actually mint these tokens as well. So these, yes, okay, so I think one of the questions was, what did you learn? And I think, what did we achieve? We successfully, of course, created this MVP. So you have a fully functional web application here, which is then linked, of course, to wallets. You can actually digitize and mint these NFTs, much with the help of course, EndMaker, which was our partner in this project. Who also wrote a very nice piece about our collaboration and what we've done and achieved during this project. And of course, verifiable history is the key to real FI or digital identity, of course. So, I think this is when we think of these areas, at least from me and a farmer's perspective, is that you don't have a lot of publicly available data. There's low digitization, so the ability to prove this or be able to provide this kind of stacked data layer, which is easily accessible for the stakeholders. Of course, you have unbiased data that's neutral and is tracked over time is really, really important, of course, for the stakeholders to work with these farmers. So yes, and maybe also mention we've been lucky enough to be featured, of course, on the town hall earlier last month about this project. And prior to that, we were also lucky enough to be part of the Cardano 360 June edition, where we did an interview. So we're thrilled about the support from Cardano and very excited to see the use case and the actual traction and activity on the platform now. So thank you very much, and we're going to keep building. And now we have solidified relationships, which I said, for Syngenta, UNCDF, World Food Program. So we are taking this to the next step, so to say. So yeah, thank you very much, and yeah, look forward to continue the work.